Disadvantages of arrays. While arrays have several advantages, they also come with certain disadvantages that make them less suitable for certain scenarios. Here are some of the main disadvantages of using arrays. The first one is fixed size. One of the significant drawbacks of arrays is their fixed size. The size of an array must be specified at the time of declaration, and it cannot be easily changed during runtime. This limitation can lead to either wasted memory or insufficient space for data. The next disadvantage is memory wastage. If an array is declared with a size larger than actual number of elements it needed, the memory may be wasted. This is particularly true in situations where the array needs to be accommodated the worst case scenarios. Inefficient insertion and deletion. Inserting or deleting elements in the middle or at the beginning of the array requires shifting all subsequent elements, resulting in a time complexity of big O of n. This can be inefficient for large arrays or frequent modification operations. Contiguous memory requirement. Arrays require contiguous memory locations to store elements. In situations where contiguous memory is not available, it may limit the size of array or result in memory fragmentation. Homogeneous data type. Arrays typically store elements of same data type. If you need to store elements of different data types, an array may not be the most flexible data structure. In such cases, a collection of structure may be more appropriate. Static structure. The static nature of arrays make them less suitable for scenarios where the size of the data is dynamic and unknown at compile time. Dynamic data structures like linked list or dynamic arrays may be more appropriate. Lack of built-in methods. Arrays in many low-level languages lack built-in methods for common operations such as sorting or searching, while higher-level languages may provide such functions. Developers in low-level languages may need to implement these operations manually. Poor performance in dynamic sizing. If dynamic sizing is required, such as when the number of elements is not known in advance, arrays may not be the most efficient data structure. Dynamic arrays or linked lists offer more flexibility in this regard. Not well suited for sparse data. For datasets with many empty or null values, arrays can be inefficient in terms of memory usage. Sparse data may be better represented using data structures designed for such scenarios like sparse matrices. In summary, while arrays are simple and efficient for certain use cases, their fixed size and limitation in terms of dynamic resizing and efficient insertion or deletion make them less suitable for certain applications. Developers often choose alternative data structures based on specific requirements of their programs.